In this video, I want to give some specific reference information when it comes to 9 and 12 lead dual voltage three-phase motor, particularly the Y and delta connection configurations, and then resistance testing of the motor windings using a digital multimeter and with a mega ohm meter. Here is a typical ball door Reliance base mounted motor, very typical for HVAC applications. Here's the nameplate that you'd see on the motor. It tells you a lot of information. It does not necessarily tell you how the motor is connected internally and does not really give you the information you need to test the resistance of the windings. What you need is this type of information here, and if it's a 9-lead delta motor, this is the configuration that you would see for connecting it with a low voltage, which is typically 208 to 230 volt, or high voltage, which is typically 460 to 480 volt. Here it shows optional thermostats. If you have a safety circuit, that would be an option that you could purchase with that particular motor. For the low voltage connection of the 9-lead delta motor, you see here where it says low voltage 2D. It's actually two separate delta connections, and I'll show you, when you see how this is connected, it's actually parallel coils. It says to power with L1, terminal number 1, number 6, and number 7. And then with L2, we're going to power 2, 4, and 8. And then with L3, we're going to power 3, 5, and 9. So the configuration ends up being 208 to 230 volts across each inductor winding. When you switch to the high voltage connection, now we're going to put a jumper between 4 and 7, 5 and 8, 6 and 9, like it says here, and we're going to connect the higher voltage to L1, wire 1, wire 2, wire 3. And now, since we have the higher voltage across a series circuit of 2 inductor windings, we're going to actually split the voltage. So you see the voltage across the winding did not really change from a low to a high voltage connection. It's just now they're in series instead of a separate power on each winding. When it comes to doing resistance testing on the 9-lead delta motor, the first thing you want to test is to make sure that all of the windings have the same internal resistance. It's just a coil of wire wrapped around an iron core, but the resistance should be the same on all of them. It's important to disconnect all of the wire connections. You never want to condemn a motor until you've absolutely tested to make sure that you know there's something wrong with it, and this is how you would do that with a digital multimeter. Make sure that each one of these windings measures the exact same resistance or fairly close to the same resistance. The next test you want to do is to make sure that there's not a shorted connection between a set of windings. There should be no resistance or any type of connection between this winding, or this winding, or either one of these two. So if you take a resistance reading between wire number 1, 2, 2, 3, and 1, 3, you should have infinite resistance, and on your motor, on your meter, it will say OL for over limit. And the last test to do is a mega ohm test, and now we're testing to see if the insulation on the windings is broken down. That could cause some damage to the motor. And we do that by connecting the common lead of a mega ohm meter to the ground lug in the motor terminal box, and then we read to terminal 1, terminal 2, terminal 3, and make sure that we don't see anything less than, for a 460 volt motor, 1.46 mega ohms, which is actually 1,460,000 ohms, very, very high resistance. And if you did have 460 volts at that high of a resistance, the actual amperage would be very low, 315 microamps, or 0.000315 amps, very, very low current. Couple notes about megohm testing, temperature and humidity can affect your readings, and you should never ever do a megohm test on a compressor, a hermetic or semi-hermetic compressor, while it's in a vacuum. And just like voltage, amperage, and temperature readings that you take, megohm readings are an important reading to have for preventive maintenance data. Moving on to the Y-connected motor, you see here the low voltage connection, the high voltage connection. This is the low voltage connection that you actually end up with two separate Ys because of the common junction that you make between 4, 5, and 6. You have the common junction here, and there's your 7, 8, and 9. So you end up with two Ys, and you're basically powering L1 on 1 and 7, L2, 2 and 8, L3, 3 and 9. And the voltage drop across each winding is somewhere between 115 to 120 volts, because you've got two windings in series. When you connect it in the high voltage configuration, now we have actually 4 windings spread out across the 480 volt power, which divide the total voltage by 4, and that's what we have across the windings. Again, same voltage across the windings regardless of the low voltage or high voltage connection. And for the high voltage, it's just 1 Y, that configuration there. Testing, basically the same. You just want to make sure that you have the same resistance across each one of these windings. When you get to this junction here where you've got 3 windings to a common junction there, you want to test those and make sure all those are the same. Obviously the resistance here should be about double of the resistance that you took on the first 3 readings. The third resistance test is to make sure that there's no short between any of the windings, and that you can do by following this information here. The megohm test, again, we're just testing for resistance to ground. We want to make sure we have a very, very high resistance. We don't want any internal current leakage in the motor that would damage would indicate damage to the windings. The last motor is the 12-lead Y delta motor, and this is much like the 9-lead motor in the Y configuration, except this common junction here is split out where we have wires 10, 11, and 12. So the 12-lead Y delta motor can be used as a 2Y or a 2D, a 1Y or 1D, just like you saw with the 9-lead Y motor and the 9-lead delta motor. But it's very important with the 12-lead Y delta motor, and I would like to do another video in the future that explains the Y delta starting configuration. But if you're going to use a 12-lead motor for a VFD or some type of full voltage starter where you're putting full voltage on the motor, you always want to connect it in the delta or run connection configuration. This configuration here if it's a 230 volt, this configuration here if it's 460 to 480. That always has been a question. You only use the Y configuration for starting, and that's only if you're using what's called a Y delta starter. So here are some of the things I want to do in the future. If you're interested in anything not shown here, let me know, and I will be glad to see what I can come up with.